So we've looked at dividing two complex numbers together and taking the square root of a complex number and managing it to get it in the format z equals a plus bi, our standard format for a complex number. What I'm going to do here, I've got 4 questions for you to have a crack at. I want you to read the questions, pause the video, have a shot at them, and then come back and check your answer with the work solutions here. So here you go. So I want you to calculate each of the following, giving your answers in the format z equals a plus bi. I've got 4 questions for you there, 3 involving fractions, 1 involving a square root. Pause the video and have a ping at them. So the first one was 7 plus I over 3 minus 4i. Now remember, for these ones we said we multiply the top and the bottom by the complex conjugate of the denominator. So in this case I'm going to multiply the top and the bottom by 3 plus 4i each time. Reason being, remember, we want to get rid of the imaginary part of the denominator. We can't split it up if we don't and not have both elements having imaginary parts to them. So if I multiply these together, I get 7 plus I on the top times 3 plus 4i. And then by the denominator gives me 3 minus 4i, 3 plus 4i. And what I can do is split top and bottom, calculate each of them, and then bring it all back together. So if I do my numerator first, so I've got my 7 plus I, and I'm multiplying that by 3 plus 4i. What I get for that is I get 21 plus 28i plus 3i plus 4i squared. So I've got 21, I've got plus 4i squared, I squared is negative 1, so I've got 21, take away 4 there, so I get 17, and I've got 28i plus 3i, so I get plus 31i. If I then look at my denominator, I've got my 3 minus 4i, 3 plus 4i. Now remember, at this stage, if we're at this point and we're not feeling quite as confident, we can multiply it all out and then get the elements together. If I'm feeling a bit more confident, remember we can use our difference of two squares. So a minus b, a plus b is equal to a squared minus b squared, and identify the a and the b and just substitute them into this sort of format. So in this question, my a is 3, so that'll be equal to 3 squared, take away my b, which is 4i. So that'll be 4i, and then it's squared. So my 3 squared is 9, my take away 4i, so 4i squared is 16 times negative 1, so it's negative 16, 3 minus minus 16, plus 16, so that then gives me 25. So now I combine both parts, and I get that 17 plus 31i over 25 is what I want. So I can then say, therefore, z is equal to, and split it up, 17 over 25 plus 13 over 25i. There we go. So that's it in the standard format that we want. Second question was 2 minus 3i over negative 1 plus 5i. Again, same idea, multiply top and the bottom by the conjugate. Now, here's a key point for you here. We know this sign gets changed, so it's going to be a negative here. You see the negative in front of the minus 1? We don't touch that. We leave that alone. So my conjugate for this one would be negative 1 minus the 5i. The real part stays the same, regardless if it's a positive or a negative number, or even 0 and it's not there. That stays the exact same. And the bottom is the same as well. Negative 1, take away 5i. So if I then do the top calculation and the bottom one, combine it all back together, I then get what I'm after. So my top is going to be 2 take away 3i times negative 1 minus 5i. So that's going to give me negative 2 take away 10i plus 3i. It's negative 3i times negative 1. I'm then going to have plus 15i squared. So I squared is negative 1, so I get take away 15 here. Negative 2 take away 15 is negative 17. I've then got minus 10i plus 3i, take away 7i. Remember, the signs have no impact here whatsoever. If they're positive or negative numbers, we still stick them in that way. If I then look at the bottom, and I've got my negative 1 plus 5i, negative 1 minus 5i. Again, I'm going to use my standard format of a squared minus b squared. For this one, my a is the negative 1, it's the real part, and my b is the imaginary part, which is 5i. And I'm going to square both and stick it together. So negative 1 squared is 1. It's going to be take away 5i squared. Well, I squared is negative 1. 5 squared is 25. So it's minus minus 25. So it's then plus 25. So I get 1 plus 25. So I get 26. Stick it all back together. And I can say fine. So z is equal to negative 17 minus 7i over 26. So z is equal to negative 17 over 26, take away 7 over 26i. Job done for this one. Now most times it'll ask you for it just in the standard decimal form. However, if you get one where you do the quadratic formula and you get decimal answers, it may ask you for set numbers of decimal places, so just be aware of that. Remember the format at once. I'm leaving it as fractions here. It may ask you for decimals. Just make sure your rounding's correct. Third one was 1 over I. Now, again, we have to multiply by the conjugate of the bottom, but the bottom is just I. But remember, this is still in the format of a plus bi. The only difference is it's 0 plus I. So my conjugate of 0 plus I is 0 minus I. So the conjugate of I is just minus I. So if I multiply the top and the bottom by minus I, I'll do the exact same thing I want. So I'm going to have 1 times minus I on the top, which gives me minus I. And the bottom is going to be I times minus I. So that's going to be minus I squared. So that's then going to be minus I over 1, which is just going to give me minus I. So in this case, if I was to have my z equals a plus bi format, that would just quite simply be negative 1, because my a is equal to 0. Just beware of that. All the numbers are written in complex form, even if the real part is 0. You'll always have an imaginary part, but the real part could be 0. And then the last question was that I wanted you to solve square root of 3 minus 4i, giving your answer in the format z equals a plus bi. Now this is the one where we set it equal to a plus bi, work it through by squaring both sides, get ourselves a quadratic and find our a and our b. So in this case, what I'm able to say is that a plus bi, all squared, equals 3 minus 4i. If I then multiply out the bracket here, I get a squared minus b squared. I'll bracket that off because that's the real part, plus 2 times a, b, I for the imaginary is equal to 3 minus 4i. So now at this stage we do what we did before and we equate the real and imaginary parts together and find my a and my b from that. So if I equate the real part, I get a squared minus b squared is equal to 3. If I equate the imaginary part, I get 2ab equals negative 4. Now, again, for the second part, this bit here, the 2ab equals negative 4, I can choose to rearrange it so that I can find the a or the b first. In this case, I'm going to actually do the a. So a, in this case, if I divide through by 2b, is equal to negative 2 over b. I then substitute that back into here, and I see what I get. So I get negative 2 over b all squared. Take away b squared is equal to 3. So negative 2 over b squared, that gives me 4 over b squared. Take away b squared is equal to 3. If I multiply through by b squared to get rid of that, I get 4. Take away b to the 4 is equal to 3b squared. If I then stick it all over here, so I get a quadratic format equal to 0, I then end up getting b to the power of 4 plus 3b squared, take away 4, equals 0. So I now have to solve this to get an answer for b squared, which I can then work through from that. So what I do is I use my quadratic formula, and I can say fine, so b squared is equal to negative b, so negative 3 plus or minus the square root of b squared, so 3 squared, take away 4, times 1, times negative 4, all over 2a, which is 2. If I take this bracket and fix it, I get the square root of 25. So what I end up getting is I get negative 3 plus or minus square root of 25, which is 5, over 2. So from that, I get two solutions for b squared. I get b squared equals 2 over 2, which is 1, or b squared equals negative 8 over 2, which is negative 4. So to get the solution for b, I have to take the square root of both of them, but I can't do the square root of a negative number without it being imaginary, and we want solutions in the real set of numbers, so b squared is just the square root of 1, which is 1, or negative 1. What I can then do is take this and substitute it back into here to get my a's. So if b is equal to 1 or negative 1, a is equal to negative 2 over 1, so negative 2, or negative 2 over negative 1, which is 2. So I can then get two solutions for that. I get z equals negative 2 plus I. I get my z2 is equal to 2 minus I. So there you go, that's your two solutions there for that one. So I've got my two solutions for the square root. The key thing at this stage is this bit here. Remember, we take the square root of a negative, we can't have that. We want solutions in the real set of numbers. So if we take a square root of a negative, we're going to get an imaginary again. We want rid of those at this stage. We want this to be the coefficient of an imaginary number, not an imaginary number itself. Now, if you end up with two positive solutions here, you take the square root of both of them, and you'll actually end up with 4 solutions for the answer. But just bear in mind that we want our a's and our b's to exist in the real sets of numbers, so we have to remember that. We have to remember and take the square root of positive elements at this stage. And there you go. That's how we would deal with a question like that.